Welcome to episode 0 of the Energy Balance Podcast. I'm Jay Feldman, and today I'll be joined by my good friend Mike Fave. So the reason that this is episode 0 is that we had already recorded a few episodes, but decided that it would be important to put out this episode first, talking about the coronavirus. But I do want to mention that throughout this episode, we'll be diving in a little bit into the physiology, but after this episode, for the episodes following, we'll take the time to really set up a foundation and help you understand the basics of our health and how energy relates to our health. So as far as the coronavirus and what we'll be talking about today, we aren't going to dive into the statistics or the political side of things. We're just going to focus on the direct health effects of the virus. So we'll be focusing on this current coronavirus in particular, and also viruses in general, how they work, how they affect our immune systems, how our immune systems work, and then the relationship between all of those things and energy. And then we'll also be talking about the things that we can do to protect ourselves from viruses, the things that we can do to support our immune function, which kinds of treatments we would want to encourage and which ones we might want to avoid. And we are going to dig into the physiology a little bit, but when we do that, I'll try to incorporate some diagrams. So if you're watching on YouTube, you'll be able to see those, and that will hopefully make it a little bit easier to understand. And we will also make sure to zoom out a little bit and relate that in-depth physiology to what that means in the real world applications, what we want to be doing in order to protect ourselves, support our immune system, all of that. So to check out the show notes for today's episode, head over to jayfeldmanwellness.com/podcast, where I'll be linking to any of the studies or articles that we referenced today. There will definitely be a lot of those. And then I'll also include some information as far as the supplements that we think would be helpful for supporting our immune function, supporting our energy systems, and then especially in relationship to the coronavirus. And then if you are dealing with any low energy symptoms, whether that's fatigue or brain fog or gut inflammation or weight gain, or if you're dealing with any chronic health conditions, or if you just want to make sure that your body is functioning optimally, that your immune system's functioning optimally, head over to jayfeldmanwellness.com/energy, where you can sign up for a free mini course on energy balance, where I'll walk you through the main things that you want to do to support energy production and the things that you'll want to avoid that inhibit that process. And with that, let's get started. All right, so let's start out by talking about what viruses actually are and how they affect us as far as our immune system goes and our health in general. And how they work, and then we'll go from there as far as the coronavirus specifically, and then what we can do to protect ourselves, support our immune function, the kind of things we don't want to be doing, which is a lot of things that are being talked about right now, treatments to avoid, and all that. So as far as what a virus is, and you had a good explanation of this, so I'll defer to you in a second, but basically it's like a signaling molecule that can't replicate on its own. It's not like a living organism like bacteria or something like that. It's more of like a parasite type thing where it associates with our cells or gets into our cells and then it kind of takes over and leads to the signaling of these inflammatory pathways, as basically a sign that kind of like something's not right, something within our body is not working properly, and then spreads or can be like transmitted between people to further spread this kind of inflammatory stress type signal. But the important thing to consider, and something that we'll talk about a lot, is that the interaction between the virus and the organism, or in this case us, is dependent on both sides. So it's dependent on the virus, but it's also dependent on our health, our physiology, our immune function, our stress state, all of that. And so if we are functioning well, then we won't be affected in the same way as somebody who obviously isn't, somebody who's immunocompromised or something like that. So,
okay.
Do you want to dig into some of the details there?
Yeah. So basically what the basis or the gist of what you're saying is that the goal is to strengthen the host as opposed to try and directly kill the virus or anything like that. But even with that said, we'll still cover what the virus is, what it does. And then we can talk about some of the specifics of treating it or preserving yourself against it or anything like that. But for the basis of the virus, I mean, depending on the virus, you have RNA type viruses or DNA type viruses, and they're basically just strands of RNA or DNA that are enclosed in certain protein structures. The viruses they replicate by injecting their DNA or RNA into the cell, and then using the cell machinery to produce more viruses. We won't go into the specifics of that. And then essentially the viruses don't produce or any type of energy or anything like that. They aren't able to produce ATP. They don't have any type of metabolic machinery. And then the basis of their effects on us are, number one, they are, as you mentioned previously, they are signaling molecules. So like the presence of a virus in and of itself has an effect on the body just by signaling the presence of the virus, or has an effect on the immune system just by signaling it. And then the virus can also have some specific effects or direct effects in the cells themselves. So what determines those effects really is the state of the host, the functioning of their immune system and the general inflammatory state that they're in, or that are not in. So if you want, we can go more specifically into COVID-19 or just coronavirus, this specific strain.
Yeah. So as some people, or at least most people I think are aware, is that this is a specific strain of a coronavirus, but coronaviruses are one of many different viruses that cause basically respiratory illness. So, which basically every winter for the most part is when there's really high incidences of respiratory illness, and we call this the flu, but most of these flus aren't actually caused by influenza viruses. There's several different viruses that all basically cause the same set of symptoms. So influenza is one of them, and then there's rhinoviruses and coronaviruses and a bunch of others. So this coronavirus strain is one of those many viruses and has some uniqueness to it, as far as the way that it affects us and the way that it then affects our respiratory system. And if we understand how it is that this happens, it can help us better protect ourselves from the effects of this virus. So we're going to talk a little bit about like the details there as far as like the physiology goes, and then we'll kind of zoom back out. So the COVID-19 basically interacts with us through the ACE2 enzyme, which is within a larger system called the RAAS system, which is the renin, angiotensin, aldosterone system. And ACE2 is primarily found in our lungs and our respiratory apparatus. So that's why you get these sorts of illnesses from COVID-19.
That's why their symptoms manifest particularly in the lungs, because the receptor or the enzymes that they target are mostly concentrated within the lungs. They can be in other tissues, but the majority of symptoms are in that area because that's where they are most concentrated. That's where the receptor, the enzymes are most concentrated, that these particular viruses hitch a ride with or infect or things like that.
Yeah. And so they're part of this larger system, the RAAS system, and it's basically a system that helps us to manage our blood pressure. And so basically what happens within the system is that when our blood pressure falls too low, or if we have too low sodium in our blood, or if we're just under any sort of stress, so any sort of sympathetic stimulation, all of those things would activate this RAAS system. And it has this, just like any other system in our body, it has these intricacies that all lead to an adaptive response. And in this case, the adaptive response is to raise our blood pressure, among other things. Basically, that raising of blood pressure comes at a cost. But so the virus is interacting within this system. And
so you want me to go through the system and then you can go through the specifics?
Sure.
Yeah. So for the actual RAAS system, we have a component called angiotensinogen that's just generally within circulation. Pretty sure it's produced by the liver. And then you have renin, which is produced by the kidney. When you have a state of either low blood pressure or low sodium in the blood, and sodium and water have like a very strong relationship within the body. So basically, anytime sodium goes somewhere, water tends to follow it. Mm-hmm. And then after that, if you have any type of general sympathetic nervous system activation, so a fight or flight response, the the renin in the kidney releases renin, because in all of those states, blood flow to the kidney can be decreased. That's basically the signal for kidney to release renin. Then renin works on angiotensinogen and converts it into angiotensin. Angiotensin is then converted by ACE1, so angiotensin converting enzyme 1, to angiotensin 2. So angiotensin 2 is the main activator of this system. And the main function of angiotensin 2 is to activate aldosterone, which is basically an adaptive or a stress hormone from the adrenal glands, like cortisol or anything like that. And it causes the reabsorption of sodium and the excretion of potassium at the kidney. The reabsorption of sodium pulls more water that helps to increase the blood pressure. And then also the angiotensin in itself and the aldosterone have blood vessel constricting properties. So now you have an increase of water or fluid, not necessarily water, but fluid in general in the vascular space. And you also have constrict the tubing or the blood vessels of that vascular space is constricted. So you have more water in a smaller space, so blood pressure is regulated. And then after that, so once you have angiotensin 2, that's the main mediator of this inflammatory cascade. But as with everything in the body, there's checks and balances on the system. So then you have angiotensin converting enzyme 2. Angiotensin converting enzyme 2 called ACE2, converts angiotensin 2 into angiotensin 1,7, which basically has anti-inflammatory vasorelaxing properties that are sort of antithetical to the effects of angiotensin 2, because it basically, you have the stress response to regulate blood pressure, and then when you have the response that's necessary, then the body basically balances it by having like a metabolic switch per se, where angiotensin converting enzyme 2 basically creates a mediator that balances angiotensin 2. So that's the basic RAAS system. The way the virus functions, which Jay will go into, is by hijacking this system. And because these angiotensin converting enzymes 1 and 2 are most, or the receptors as well for angiotensin, the angiotensin 2 receptor is strongly present within the lungs, you'll see the viral symptoms manifest in these areas, even though the viral response is systemic.
Yeah. And one thing that's important to note too is that as far as angiotensin 2's effects of vasoconstriction and the activation of or the production of aldosterone, so all of the vasoconstricting type effects that come from angiotensin 2, those are mediated by what's called the angiotensin 2 receptor. In this case, it's the first receptor, so angiotensin 2 receptor 1. Which is typically, when we're talking about angiotensin, we don't necessarily say the 2. So it's angiotensin receptor 1 is normally how it's referred to. But that's an inflammation driving, like it creates this general immune response, so inflammatory response. So that inflammatory response basically disrupts the metabolic machinery, and that's what leads to the vasoconstriction. Is that constriction is basically the result of the stress, the result of this inflammation, and that's how all these effects manifest. So this receptor, the angiotensin receptor 1, is kind of like the main signaling part through which this inflammation goes on, and it also leads to as you said, the production of aldosterone, but also serotonin and estrogen and noradrenaline, basically, and other things too, like all sorts of inflammatory cytokines. All of that is happening through this receptor that's driving this systemic inflammation, but also localized inflammation to create particular responses. And so as far as ACE2 goes, which is what's bound with what the coronavirus is trying to bind with, at low levels of angiotensin, the first receptor, angiotensin receptor 1, is bound with ACE2. So at those low levels of angiotensin, it can't actually bind with the receptor, and instead that's when it gets converted to angiotensin 1,7 through the ACE enzyme, or ACE2 enzyme. And so when ACE2 is bound with this receptor, the coronavirus isn't actually able to bind with ACE2 because ACE2 is already associated with this receptor. But then when you have high levels of angiotensin, when this RAAS system is activated, which leads to high levels of angiotensin 2, then that causes the dissociation between the angiotensin receptor 1 and ACE2. And so that first allows angiotensin to bind with that receptor, the angiotensin receptor 1, which leads to this whole inflammatory cascade. But then it also, in this case, allows for the coronavirus to bind with ACE2, because now the ACE2 is disassociated from that receptor and it's basically free and able to be bound. And then what happens is that when you have this binding between coronavirus and ACE2, you end up with a degradation of ACE2. Basically, ACE2 is blocked from having all of its anti-inflammatory effects. So what it's doing is basically taking the brakes away from that whole system and creating this drive of this inflammatory response, which is what leads to all of these other symptoms. So all of the other symptoms, but all of the symptoms of the illness. So the pulmonary edema, which is responsible for that respiratory distress, the hypertension, the vasoconstriction, any of the fibrosis that's going on in the lungs, the inflammatory response, the cytokine production, all of that is a result of taking away the brakes, the ACE2 brakes, and driving angiotensin through, or angiotensin's binding with that receptor 1 and creating this basically uninhibited inflammation. And as I had mentioned earlier, a bunch of the resulting hormones that get produced here, the serotonin, estrogen as well, which basically angiotensin receptor 1 has aromatizing properties. So you have estrogen, you have serotonin production, you have adrenaline production, you have aldosterone production. Yeah, all of those things contribute directly to this lung injury, this fibrosis, this edema. And those are all the things that are responsible for, not even responsible, these are the effects that are occurring when the virus is active. And these are all the things that we want to, of course, prevent from happening. So a lot of times when we're thinking about the damaging effects of the virus, it's not necessarily the virus itself, but all of these downstream effects that are happening as a result. And it's worth talking a little bit too about the ACE2, some of the confusion around this, where it's known that because coronavirus binds with ACE2, originally people were thinking that having high levels of ACE2 is a bad thing because it's going to allow the coronavirus to bind and then replicate. But what they're actually finding is that having the higher levels of ACE2 is protective because it's the anti-inflammatory part of the cascade. And when you have low levels, right,
it turns off the inflammatory cascade. So if you don't have the ACE2, then you have angiotensin going unchecked, especially if it's not bound, especially with less ACE2 binding to the receptor.
Right, exactly. And so the concern is that the coronavirus is stopping ACE2 from having its effects, and that's what's causing everything. So originally, some people were suggesting that we want lower ACE2, and all of these resulting ideas as far as treatments go that resulted from that. But in reality, it's the opposite, where the higher levels of ACE2, the better, and the more protection. And that's also evidenced by the fact that the youngest people are at the least risk for coronavirus.
Yeah.
And younger people have much higher levels of ACE2. Age is one of the primary factors that determines how much ACE2 you have. And so it's much higher in younger people versus older people, which is also just a testament to the fact that ACE2 is just directly tied, the expression of ACE2 is directly tied with our overall metabolic function, because we know that aging is really just just a representation of our energetic state. And so as we age, as we have less available energy, stress increases, and then is what actually results in aging. Then we also know that ACE2 is associated with that. So it's another way of saying that keeping our metabolism up in general and slowing down aging or reversing aging by doing that is actually going to help keep ACE2 expression higher.
Yeah. So as far as what you said with the specific effects of the coronavirus and angiotensin, there's a few ways that we can protect ourselves from coronavirus and from the negative effects of coronavirus if you are dealing with coronavirus. So the first one would obviously just don't have a lot of angiotensin 2 or angiotensin. When you don't have a lot of angiotensin, then you basically turn off that metabolic switch, which is dependent on the angiotensin concentration to unbind the angiotensin 1 receptor from ACE2. Mm-hmm. So if you don't have a high amount of angiotensin, aka you don't have a high amount of stress, your fluid and electrolyte balance is normal. You have adequate sodium, you're not drinking gallons of water a day or anything like that. Then essentially you keep angiotensin 2 bound to the angiotensin 1 receptor, which number one doesn't allow angiotensin, the whatever circulating amount is there, which should be low to begin with based on this, to bind to the receptor and cause the inflammatory cascade. But then it also doesn't allow coronavirus to bind into the ACE2 receptor and inhibit it from its function. So then after that, that's obviously step number one. That's how do you prevent coronavirus infection per se. It's probably the most basic step to start.
Yeah, well, and I want to make a note there too. Like, a lot of people are probably surprised to hear that you're saying, like, don't drink too much water, make sure you're having enough salt. There's a lot of misconceptions there, but one thing that is acknowledged is that when you have too low salt in your blood, which happens when you eat too little salt or when you have too much water, which dilutes it, it activates this RAAS system. And again, it's a protective measure in order to make sure that you can keep your blood pressure stable, you have enough blood flow. And when that's not happening, then you need to activate this adaptive system. But especially in this case with the coronavirus, you want to make sure that the system is not activated. So you want to make sure you're not drinking too much water and that you're making sure you're getting enough salt. And I have a couple articles dealing directly with salt and water intake and all that. So I'll link to those because there's, of course, a lot of intricacies there. And I don't want to spend too much time talking through that. But yeah, so basically what you're saying is make sure you're not drinking too much water, not eating too little salt, and that'll help to keep the RAAS activation lower. And then also, as we were talking about earlier, like any sort of sympathetic activation, so any sort of stress, fight or flight situation is also going to increase the RAAS system activation. And we'll talk through a little bit more later, just the details as far as how we can keep stress low, keep energy high, and what that means on like the physiological level. Yeah. But all right, I'll go back to you. I know I interjected, so.
That's okay. So then after that, so if your angiotensin is high and you basically have it activating on the receptor, the next thing to do from there would be to stop the cascade of effects that continued like further down. Mm-hmm. So the cascade of effects would be, you want to inhibit the aldosterone to some extent, you want to inhibit the serotonin, you want to block the estrogen, and then you want to lower the adrenaline, and you want to basically you want to also inhibit like the inflammatory cascades. Mm-hmm. And so some basic steps to do these types of things. Basic things to inhibit any type of adrenaline response is have enough saturated fat in the diet, have enough carbohydrates in the diet. You can use things like taurine, you can use things like magnesium, you can have obviously adequate sodium intake in the diet. For aldosterone or anything like that, again, sodium. There's some, if I'm not mistaken, I'm pretty sure that progesterone and DHEA have some anti-aldosterone properties. And then for serotonin, you could take like Benadryl or cyproheptadine, which are over-the-counter antihistamines with anti-serotonin properties. Then for estrogen, you have basic aspirin, which also inhibits the inflammatory pathways of COX and LOX. And we'll get to that later on, talking about unsaturated fatty acids, and then prostaglandins and cytokines like factor in directly into the system. And the last one is a very specific recommendation, which would be to use losartan, which is an angiotensin receptor blocker. So I'm not saying to basically take a kitchen sink approach and blast yourself with all these drugs and compounds. But these specific compounds and these specific resources are what you can use in general to basically limit the damaging effects. And then some even more basic ones would just be to inhibit something like nitric oxide. And you can do that via red light. You can use methylene blue, things like that.
Inosine, urea.
Inosine, yeah. Exactly, yeah.
Yeah, so we'll talk through, what we'll do is we'll list at the end, like, we'll kind of go through all the different supplements, medications, things that would be helpful as a protective measure. And then also if you were to have coronavirus, to prevent it from becoming worse. That was a good overview. And then I also want to mention, as far as just diet, lifestyle, all of those things directly affect any sort of stress that we're under. They directly affect the inflammatory response. So we'll, of course, like, we can't go through like, here are the things for a perfect diet in 30 seconds, but that's one of the things that we focus on a ton on this podcast. So all the future episodes, we dig in through the details of that, because it is relatively complex, especially because of all the misinformation out there. Yeah. So
there's other things to mention too, just to like, we can go through it at the end, or we can do it now, whatever you want, but just to enhance immune response in general too, you have your fat soluble vitamins, and then you have vitamin C and stuff like that. So all those things are viable therapies to hit the pathology or the pathophysiology of this particular virus from multiple different angles.
Yeah. Yeah, I guess. Okay, so yeah, why don't we talk through like the details of some of those things that you mentioned, just different supplements that can be helpful. Like we'll leave the diet. I mean, you mentioned a couple things there: eating enough carbs, eating enough saturated fats, getting enough protein, getting enough nutrients. Like those are a lot of the super basics. But yeah, all future episodes will be talking about those things.
Okay.
But we can talk through some of the supplements that can be helpful, and then as far as like the treatments and medications go, I would say, as you said, losartan is a good one. It's an angiotensin receptor blocker, which means that it keeps ACE2 bound with the angiotensin receptor 1 so that inflammatory pathway can't get stimulated by angiotensin. And it also means that the coronavirus wouldn't be able to bind with ACE2. So that's a pretty good pharmaceutical that would be helpful if you are, either at high risk or if you have the virus and you're, getting significant symptoms. And then also you mentioned the anti-serotonin ones, which would help to protect against a lot of that inflammatory cascade. So that's Sinanserin.
Or Metergaline.
Yeah.
I think they were using Sinanserin in China.
Yeah, I think so.
Yeah. And just so people know, serotonin, the name for it literally suggests partly what it does. Sero, like sero or serum, involving the vasculature, and tonin, increasing tone. So as far as increasing vasoconstriction, serotonin is one of the primordial, like direct mediators of doing that.
Yeah, it's typically thought of as a beneficial thing, but if you're looking at the physiology, at least from this virus, it becomes clear that the serotonin is heavily involved in any sort of respiratory distress and fibrosis.
And leakiness.
Yeah, edema, leakiness, which goes along with that whole inflammatory cascade, the whole metabolism inhibiting cascade. Yeah, and so there's a lot of confusion about that. I've written about at least why the serotonin producing drugs are definitely not effective for like depression and things like that. But yeah, I mean, it's again, like we could have whole episodes on any of these individual compounds and things, and eventually we will. But yeah, we'll move on from there. So outside of pharmaceuticals, let's talk through some of the supplements. So you mentioned aspirin as a good one to stop the inflammatory cascade. There was some concern in the mainstream about using aspirin because it increases ACE2. But as we were talking about, we actually do want to be increasing ACE2, and there was all that confusion about it, but it seems pretty clear now. And I'll link to all that research. But so aspirin is a good one for stopping inflammation and keeping ACE2 potentially higher. You also mentioned some other things to block that inflammatory cascade.
Well, and just before you go with aspirin, it also is an aromatase inhibitor and things like that.
Yeah.
And then it will counteract some of the serotonergic properties and some of the edema and the fibrosis that can happen in the lungs from this particular disease.
Yeah. Yeah.
So as a general substance, aspirin is very helpful.
Yeah, absolutely. Yeah. And then, so nitric oxide is another kind of main mediator of that inflammatory cascade. So as far, and kind of goes hand in hand with serotonin and histamine. So as far as reducing nitric oxide goes, you had mentioned red light is really important. Methylene blue is a compound that can help with that, a supplement that you can get. Inosine is another supplement that's really helpful for keeping nitric oxide low.
Yeah. And it's also directly antiviral, but that also may be through the nitric oxide pathways.
Right. Yeah. All of the aspirin, methylene blue, inosine, and then a bunch of the other ones we'll talk about too. They've all been shown to be directly antiviral, meaning that they're helping to protect against the responses to the virus, which is really where the issue is.
Yeah. And then specifically in regards to like the leakiness, something that's been mentioned a lot is using vitamin C, which has they're talking about IV vitamin C, but for somebody who doesn't have any type of like symptom or hasn't developed coronavirus, just making sure that you're saturated with vitamin C in general from fruit sources would be helpful overall. And great sources for those could be like really high sources in particular. It could be something like acerola, which you can find frozen, or camu powder, or if even just for regular fruits, just some fresh squeezed orange juice, pineapple juice, any type of fresh fruit, or even some of the dried fruits are okay for vitamin C and things like that. And those in general, vitamin C as general properties in, number one, the immune system, but also in maintaining the collagenous structure of the body overall.
Yeah,
so making sure that things don't get too leaky.
Yeah. And preventing fibrosis and
exactly
slowing down, as you mentioned, the inflammatory cascade.
I mean, in if you want to see a general idea of what vitamin C's effects are overall, if you look at the disease scurvy, the general process that happens with scurvy is leakiness of the vasculature and basically destruction of the membranes and things like that. So vitamin C has a general effect like that. Now, whether or not ascorbic acid, like synthetic ascorbic acid, is beneficial or not, I know in the peat steer there's questions about that and whatnot. I mean, the intravenous stuff may be helpful. There's articles online showing the use of thiamine, vitamin C, and cortisone to treat sepsis, in particular ARDS, which is acute respiratory distress syndrome, which is something that happens with coronavirus. And it does it by maintaining the membranes. And sepsis in this case, because in all of these inflammatory conditions, they have the same, whether the pathways are a little different and whatnot, it's the same general process occurring. So with sepsis, rather than having a virus, which is an inflammatory signal, you have endotoxin, which is a cell wall component of bacteria, which is an inflammatory signal. And all of them signal to the body an inflammatory process or an invasion or something like that. And all these pathways start to happen or start to be turned on to try and deal with the situation. So when you have and there are certain nuances in different situations, but if you can use vitamin C in ARDS from endotoxemia or sepsis, then you will probably be able to use vitamin C, intravenous vitamin C, in ARDS from coronavirus, especially because in particular, vitamin C has a very general effect on the immune system and on maintaining the membranes of the body and the collagenous and the vascular structures, which are targeted in these particular diseases. And that's basically where the biggest problems occur. You start having a distribution of water in different areas, and because the energy flow is disrupted and the inflammatory pathways are ratcheted up to a very high level.
Yeah. And so basically just to dive into that last point a little bit, is that you have edema, you have water buildup when the cells aren't properly holding the water because they don't have the energy to do so, which happens when they aren't properly producing energy, which is a result of all these inflammatory processes going on and different hormones that are being produced and cytokines that are being produced. So those stop the cells from properly producing energy, which stops them from holding water properly. And then you have the swelling.
Exactly.
And fluid buildup, which is in this case a huge issue in the lungs. That's what leads to the respiratory distress.
Yep,
And
exactly.
ARDS that you talked about. It's so important what you said is that we talked a lot about like the specifics of COVID-19 and how exactly it's working and what we can do exactly for that. But that's more just because it's super relevant right now. But all of these things are very general processes. Like the general idea is that you have inflammation and stress and inhibited respiration, inhibited energy production. And those are pretty much the same, whether it's caused by a virus or a bacterial infection or any sort of quote autoimmune condition or any other chronic health condition. Like the things that we're suggesting for this are not, hey, this specific supplement kills COVID-19, even though a lot of them have been showed to protect from it or inactivate it. The general idea is more of supporting proper immune function, reducing inflammation, supporting the metabolic processes, inhibiting the hormones like serotonin, nitric oxide, estrogen that are part of that inflammatory cascade, and keeping the metabolism up. So it's when you start to kind of reduce this infection or any infection to, you need to do like the very specific thing that is only good against COVID-19, that's when you start to introduce dangerous treatments or things that typically come at a higher cost. And we can talk about some of those treatments too, but it's what we're talking about, and the perspective we're coming from is kind of looking at COVID-19 as an example of a very generalized process. And the more that we're doing to keep a healthy diet, and the more that we're doing to keep a healthy environment, have a lot of sunlight and low psychological stress and things like that, the far better off you're going to be for this virus or any virus.
Yeah. I mean, the first step that we talked about was literally just inhibiting the overproduction of angiotensin 2. Mm-hmm. And that literally comes down to keeping stress low and making sure that you have enough fluids on board and you're not too much and you have adequate sodium.
Yeah. And you want to be doing that always, like not just
in general.
Right now.
That's not just for the virus. That's like for living in general. You want to make sure that you're properly hydrated, you have enough salt, and that you're not overly stressed all the time.
Mm-hmm.
So,
and properly hydrated normally means drinking less water, just compared to like what is typically
you don't need to drink
recommended.
gallons and gallons. I mean, if we're gonna go out there, I mean, I would prefer to just drink juice, but that's an entirely different story.
Yeah.
And then in general, like we're talking about very basic strategies that regardless of whether or not they're used for COVID-19, they could be used just in general. So making sure that you have adequate vitamin C on board, that means that you drink enough juice, you eat enough fruit. And then the other things that we haven't really delved into yet are the fat soluble vitamins like vitamin D, vitamin A, vitamin K, and then vitamin E. 3 of those, vitamin A, vitamin K, and vitamin E, are all dependent on having a proper diet. And then vitamin D is making sure you get out in the sun. And
vitamin C too.
And vitamin C, again, is proper diet. So if your diet is proper, you're sleeping well, your stress is on the lower end, and you're getting some sunlight, then your immune system in your body should be functioning properly. And things like COVID-19 and all these viruses and bacteria and whatever else that the modern media and people freak out about should be a relative non-issue. I mean, and nurses will tell you this, not many nurses, even people who aren't very healthy, who don't take that much care of themselves, and Lord knows some nurses don't take care of themselves.
Yeah, and doctors, and
doctors
in the healthcare
as well.
Field, yeah.
And they'll go in there and they'll tell you, you don't get sick. The people who often are very sick, and you can look at this in some of the news, like for example, with what's going on with Italy, they have tons of comorbidities. The people who get C. diff are people who just came out of the ICU and went on multiple rounds of antibiotics. The people who are getting Candida auris and MRSA and things like that have been in the hospital for weeks, exposed to these things for weeks, laying in hospital beds for weeks, working with nurses and other people who have been exposed to these things for endless amounts of time. And they're in compromised states. They don't have any sunlight. They're eating hospital food. They're getting tons of medications. They already have diseases. That's why they're in the hospital. Or they have major surgeries, and the surgical, either the implants or the incisions are getting infected. And that's because you have very large portions of the body open and with people in compromised states. So the basis here is that the people who have to worry are people who are compromised. And basically, we'll tell you about the specific things you can do here and the different pathways and whatnot. And if that is really what makes you comfortable, so that you understand it, so that it's not fear of the unknown anymore, that's fine. But the basis of all of this is, if you're healthy, if you take care of yourself in general, you sleep, it doesn't even require, like, most people don't get 8 hours of sleep a night. Mm-hmm. If you're getting like 6 to 7 hours, you're doing better than a lot of people. I'm not saying that's ideal. And then you're eating 3 square meals a day, and the food that you're eating is good, and you're getting some sunlight, and you're doing some basic exercise. Like, those are the basic protective effects. The body is meant to handle these things. We are exposed to flu virus. We're exposed to all these different bacteria. I mean, there's statistics showing that 30% of people are carriers of MRSA, which is antibiotic-resistant staph. People carry it, and they don't have any reactions to it. Why? Because the immune system is meant to handle these things. I mean, there's studies showing that just bacteria in your basic flower or basic plants or the potted plants that you have, or people bringing in flowers to the hospital, have tons of antibiotic-resistant bacteria teeming in the water and on the leaves. It's a part of life. It's just how things go. Before the advent of the modern media talking about antibiotic-resistant bacteria, there were tons and tons of strains of bacteria resistant to many different types of antibiotics. It's not new. It's been going on forever. I mean, so now certain strains that weren't resistant before are resistant. Yes, that is the issue. But overall, we've been exposed to all these types of things from time immemorial, like forever. It hasn't changed. And the immune system is developed to deal with these things as long as you give it the necessary supplies, context, whatever you want to say, for it to function well. And that's the basis of what we're talking about. Yes, those specific pathways can be helpful, but all the stuff we're going to recommend here is relatively general. And then the specifics that the most specific thing we'll probably go into is losartan, which we already have. And then after that, Benadryl is basic. People take Benadryl every day to sleep. Aspirin is basic. People take their daily aspirin. Vitamin C, vitamin D, eating a good diet. All these things are what's paramount. It's not these random, obscure treatments and dangerous drugs and dangerous cocktails and extremely invasive procedures that make the difference for people. And as we'll get into, a lot of these procedures are dangerous, and they can make the situation much worse. So I'll leave it there.
One thing I want to mention too is that obviously a lot of people part of the concern with this virus is people are saying, oh, well, I know people who are generally healthy and they are getting sick. And it's happening a lot with healthcare workers too. I've heard of, not people I know directly, but I've heard of, healthcare workers becoming sick or potentially dying. And an important point to consider is that even the people who are trying to eat healthy or be healthy in like the modern world, I think for the most part, there's so much misinformation and the general guidelines are so misguided that, and this was us too, like this was us for a long time, is that we thought we were doing the things that were healthy and it took us through a long journey, but we were actually hurting ourselves a lot of the time. And that's why we are doing this podcast, is to try to help people, to steer people in the right direction and help you understand what kind of things are actually helpful and what we actually do want to be doing so we have a strong immune system and that we don't have to be worried about something like this. But yeah, I think it's a testament to also the conditions being ripe for something like this virus to affect a lot of people in a more intense way, because they already aren't healthy, and even younger people, like the incidence of all sorts of chronic conditions in younger people is skyrocketing.
Cancer, autoimmune disease, fatty livers in children, like 10, 12 years old, crazy things. Just tons and tons of different diseases, digestive disorders. Yeah,
exactly. So, and speaking of which too, speaking of misguided information and alternative views of nutrition and whatever, I know you mentioned fruit juice and fruit over water, for example, and that's jarring to a lot of people. And stuff that we'll be talking about in future episodes. But, just so people understand, we see the vitamins and minerals in there, and even the sugars, including the fructose, as beneficial. And that's a whole other topic. And, there's so much more to dig into there. But yeah, a lot of, a lot of the things we're suggesting, I know are maybe antithetical to a lot of things that we've generally heard. But, yeah, I don't know where else I was going with that, but. Yeah. But as long as we're doing the things to support our health in general, support our metabolism in general, we're okay. And so that's where our focus is.
Yeah. And that's the basis for all diseases, not just coronavirus. That's heart disease, that's diabetes, that's autoimmunity, that's every single disease. All these chronic diseases, they all come down to this basic paradigm. Mm-hmm. And it's not just me and Jay here just making things up as we go. This is based on research. The research clearly shows the importance of maintaining a proper immune function, the importance of getting adequate energy, having adequate energy production, all these types of things. And there's a general basis that all these things fall under, and that's where we're coming from. And that's where I think most people need to come from, instead of getting stuck in the minutia of different pathways and medical treatments and things like that. There's this one compound that will cure. It's a paradigm. It's a system. Mm-hmm. And I mean, that's basically the point here. Well, you have the specific pathways. Those are helpful to know, and they're interesting and whatnot. But the thing is all these pathways feed back to the same place.
Yeah, you have to look at it in the greater context.
Exactly. You have to have the greater context. So when you talk about fibrosis and edema in the lungs, and then a destruction of the membrane, transport of gases and things like that, that all has inflammatory mediators that mediate that, yes. And the thing is those inflammatory mediators happen to do the same thing in almost every inflammatory condition. There's a general process that occurs. from the inflammation. It's the same, whether the triggers are different, the same inflammatory process occurs. So there's a basis for all of this. It's not just like this happens here and then this happens here. It all happens across the same thing. The membranes becoming leaky and the loss of structuring of water in the cell, and then the subsequent development of fibrosis is a general fact of inflammation. Whether it's from coronavirus, whether it's from bacterial infection, whether it's from radiation, whether it's from cancer, it doesn't matter. They're all the same processes. They have different triggers. They may go through specific little different pathways that we have mapped out, but it all comes down to the same thing, and that is energy production. That is entirely energy production and the structuring of water in the cell.
Yeah, which is a result of energy. It's just
energy, exactly.
Yeah, just the way it exhibits itself. But
yeah, the structure, energy and structure, and this is generally Ray Peat's basic hypothesis, is that energy and structure are interdependent on every single level, which means that they're related on every level. They have basically it's a cyclical relationship amongst each other. It's a never-ending loop between each other. You increase your energy, then you increase your structure. When you increase your structure, you can funnel more energy. When you funnel more energy, you can increase your structure. It either feeds forward or it starts to unwind itself. And when it starts when you destroy one part of the loop, when you destroy structure, when you go in and you have a physical damage to the tissues, then you start to lose the ability to produce energy. And that's why when you say somebody gives you a cut, or say somebody I don't know, you break a bone, then you get the edema. And that is literally the physical damage causes a breakdown of the energy structure. And then that causes the edema, which is a further breakdown of the structure. And then the body has to reheal itself.
Yeah.
Whereas in these situations, when you have some type of virus or bacterial infection, those inhibit energy production. And then you see the breakdown in structure. And that's why you see edema in the lungs and fibrosis of the lungs in coronavirus.
Yeah. I mean, I would normally say that the edema is secondary to the direct damage, the direct disruption of energy production, and then the inflammatory processes that follow. And then I would typically say the edema follows that. I mean, at least like on a larger scale. I guess on a small scale, you definitely have it. But yeah, I'm glad that we talked through that. Of course, that's what we're focusing the whole podcast on, is how we can look at health through the lens of energy, nutritionally, exercise-wise, movement, sunlight, supplements, everything. So we'll leave most of that for the future, and let's circle back to some of the specific things as far as
COVID-19.
Yeah, COVID-19, antiviral stuff. I want to talk through a few other compounds or immunosupportive things, and then I want to talk through some of the treatments that are going on now for COVID-19 and why they might be making things a lot worse.
Yeah.
And then we'll see where that takes us. But
okay.
So just a few other things that are generally antiviral in the same way would be lysine, and then zinc or selenium if you're deficient in either of those, which a lot of people are.
Monolaurin,
and then
which is from coconut oil.
Yeah. And amodin is another one that has been coming up a lot as far as specific effects on COVID-19, and then also just general antiviral effects. So those are all things that you might want to look to. And then B vitamins, which I don't think we mentioned, but of course, if you have a good diet, you'll be getting a lot of B vitamins. As long as you're eating high quality meats, some organ meats are really high in B vitamins.
Eggs, milk, fruits.
Yeah. But then also supplementing specifically B1, B2, B3, B5, and B6, as long as they're in the right.
in the form of niacinamide as opposed to niacin.
Yeah. I was going to say, as long as they're in the right forms. Like those supplements, or those B vitamins in particular, are shown to be very strongly supportive of metabolism, anti-inflammatory, antiviral, all those things. So,
and then specifically, just as before you continue to circle back to amodin, the good sources of amodin are Cascara sagrada in an aged form, and then if you have properly prepared aloe.
Yeah. And then one that we didn't mention too, that's being talked about a little bit, are some of the hormones. So progesterone, DHEA, pregnenolone. Those are just very general pro-metabolic, anti-stress,
immune enhancing, specifically for DHEA. And then they do have specific, like progesterone, as I said earlier, I'm pretty sure has anti-aldosterone effects. So it directly opposes aldosterone. And they also directly oppose, exactly. And then they also directly oppose cortisol, and then the activation of the adrenal gland in general, which would be the sympathetic nervous system, which again directly affects the angiotensin system.
Right. And so again, just like anything else, it's ideal if we already have, if us as an organism, if we're already producing enough of those hormones, like we would prefer that. We'd prefer to endogenously produce enough progesterone and pregnenolone and DHEA. But of course, that's not always the case. So careful supplementation with those can sometimes be helpful too. And again, if you're in a compromised state and you are concerned about the virus, then that would definitely
those would be helpful. Yeah.
Yeah. So let's talk through first some of the more, not like the
so you talk through the drugs, and I'll go through the ventilation and all that type of stuff if you want to do it that way.
Yeah, we'll talk about some of the current medical treatments that are being looked at for COVID-19, and then I also want to talk through some of like the colloquial things that are being suggested to support the immune function, support the immune system and stuff that we might not want to be doing. Things like omega-3s, but we'll get to it.
Gotta eat your fish oil.
Yeah.
All right. So if you want to go through what interferon and chloroquine.
Yeah. So
chloroquine, however you pronounce it.
Yeah, I pronounce it chloroquine. I hope that's how it's pronounced.
Whatever.
Yeah. So a couple of the medications that are being looked at as far as treating COVID-19, chloroquine and hydrochloroquine is one type of medication. And then there's some interferon medications. So I think it's interferon alpha 2B is being looked at. So the main concerns with the chloroquine and hydrochloroquine drugs, which are used for malaria or anti-malarials, they've been shown to have some potentially scary side effects, that family of drugs. And side effects.
Fair, they are not new drugs. They've been around. They've been used for malaria, and they've been used for I'm pretty sure rheumatoid arthritis and other autoimmune diseases like lupus.
Yeah, and so my biggest concern there would be those quote unquote other effects or side effects. Basically, they've just been shown to have pretty severe neurotoxicity. I mean, they're pretty easy to overdose on, which just it kind of lends itself to how toxic they can be potentially. And there's just a lot of neurotoxic type effects that people or that happen when people use these drugs. So it's just, again, it's basically the idea of stopping the virus while also stopping ourselves, but just stop the virus first and we'll be able to survive it. But yeah, I mean, so that's where most of the concern is there, just that there are so many other options that are also therapeutic and beneficial as a whole, whereas this other idea of like kill the virus type thing and just hope that it dies before we do is typically more dangerous. So I would say the chloroquines kind of fall in that category. And then as far as the interferon medications go, so interferon alpha 2B is the medication that they're looking at being used for COVID. And that's the one that was being used in Cuba. And they've been talking about it as being effective. And that was kind of going around a little bit in the media. But it's worth noting that it's a pretty intense medication. It's also used for like as a chemotherapeutic drug for cancer. And the side effects are pretty severe as well. And they're kind of, listed and well known. But the reason for that is because the interferons are basically part of this
antiviral system.
Yeah, adaptive system, which is somewhat it's involved in viruses because it's part of the anti-inflammatory, or it's part of the adaptive inflammatory response. So it's basically when things are going really bad and you need to like signal this distress and hope that you clear out enough of the damaged tissue and the potential pathogen with it. That's kind of what the signal is a part of, but you end up driving inflammation even harder and driving damage even further. And again, it definitely falls in that category of let's just hope that we kind of like with cancer treatments, which, what do you know? It's also a chemotherapeutic drug, but it's like kill the cancer before we die kind of thing. And it's kind of the same idea with using it for the viruses. So definitely I would say is not on the safer side as far as medications go, which is evident just by the tons of side effects that are shown from it, but also just by understanding the mechanism. It's not something I would recommend.
As far as I understand, they're both like a general, I guess, analogy would be like, if you had a zombie apocalypse, you just nuke the city. just bomb the entire city and hopefully some people survive and all the zombies are wiped out type of deal.
Yeah.
And as far as, because I know more about chloroquine than I do about interferon alpha, I never even considered that a treatment option. but from what I understand, it also is immunosuppressive. And I don't think that's a good thing overall, especially like a lot of the autoimmunity drugs have direct immunosuppressive properties, and I'm pretty sure chloroquine works by having immunosuppressive properties. And that I don't think that's a good thing overall.
Yeah, this whole idea of immunosuppressive versus immune boosting, there's a lot of, and we'll talk about that in a second, but there's a lot of like confusion there.
Yeah.
But yeah, I mean, yeah, like in reality, you never want to suppress the immune system, but we'll talk about what that means in a second.
I mean, and in those situations, the suppressing of the immune system, it basically stops you from having symptoms, but it doesn't deal with the underlying process.
Right.
And that's a problem. And the issue that this comes to, and why this is a hard conversation, is because then it goes into the theories of the immune system function. Mm-hmm. And you have the commonly accepted theory of attack invaders, and then you have the other theories that involve like a sort of like a cleanup system or like a maintenance system of tissues. Yeah. So the question when you go into those type, and in general, when you look at any of the immunosuppressive drugs, especially some of the newer ones coming out, or even some of the antiviral drugs that they're talking about in general with some of their immunosuppressive functions, those things increase your risk for other diseases drastically. I mean, some of the new monoclonal antibody drugs and things like that directly increase your chances for infection, like tuberculosis or cancer or different things like that. So yeah, you don't have symptoms, or you may get rid of symptoms, or chloroquine doesn't work specifically like that for coronavirus. But yes, it gets rid of the symptoms, which is what presents as the problem, at least consciously for the person. But physiologically, it causes way more damage that won't show up until later on. And some of these drugs we don't know, or some of them we even do know, that later on they do have very toxic effects. Mm-hmm. And so there's, again, you only start to resort to these types of treatments when you don't have a general context to understand where things are coming from. And there's much safer things that can be used to prevent this process than these sort of like bazooka methods of just, I'm going to just blow everything up and hopefully the virus is more damaged than the body. And it's just like, okay, so then you solve that one problem, what happens next? And a lot of people aren't asking these questions. They're just like, oh, I have coronavirus, which let's put this into perspective. For most people, for the majority of people, this at worst is the flu. So you have like 1 to 2 weeks of not feeling good, and then you're fine. Yeah. However, you got to, for most people, you get past that. So going and trying to take these relatively obscure but very often dangerous drugs to solve this problem one time is not an answer, especially for people who are already compromised. You want to give some of these people who have multiple comorbidities these drugs that get them past the coronavirus and then cause problems later on. I mean, that's really the question. That's a lot of times what we're getting to. Yeah. And sometimes are we compromising them more than they would have been if we had just used supportive therapies and let them ride out the virus? Yeah. Yeah. It's like you have so what I was talking about earlier, and I don't know if I described it that well, but like, for example, with cancer, it's kind of like just drop this bomb, as you were talking about. Like, you just try to kill everything and you just hope that the cancer dies before you do. And so you're damaging everything, but you just hope that we survive it, and it leads to all these other problems that A, are avoidable, and B, are pretty costly. And especially if the cancer comes back the second time. Right. And then you've already bombed the city. So now you have no resources to bomb the city again. and the city's just destroyed. If you bomb it again, it's just done. Back. Yeah, it's cooked. So it's like, what are you trading? What's the risk versus what's the reward? Especially when there's other options on the table. That's really where the questions come in. Are there other options? We're saying yes. Yeah. And in general, and the thing is, for most people, these things shouldn't even be options to consider, because for most people, they're going to ride out the virus at least from what statistics are showing. Even if they're showing that it's worse, even if they're showing whatever crazy mortality rates that they're showing, and whether or not they're real, we're not going to talk about that. But even with those, what were they saying in China? 2%. So that's saying for the other, what? Well, it depends on which study you look at. I've seen from China 0.66%, but yeah, but even if it's as high as 2, if it's as high as 2, how many people go into severe crisis? We can say what, 10 there's 10% going to severe crisis, which is I would say probably a generous number, and then 2% get into like really severe issues that require talking about this type of stuff. That's probably also a very generous number. So then we're saying 90% of people should be fine.
Yeah. Above. Yeah. Yeah. Well,
Yeah.
oh yeah. I see what you're saying. Yeah.
Yeah.
Yeah. And I want to talk also about the idea of immunosuppression. So if we think about it on a smaller scale with something like cortisone, which is generally used for immunosuppression, is generally used to reduce symptoms, whether it's like a local irritation or any sort of inflammation type symptoms. And cortisone is just, it's basically our stress hormone, cortisol. And it's produced as like, as we talked about, like as one of those braking mechanisms. When you have all this inflammation going on, it's like, all right, like we need to suppress everything. That's basically what you're doing with cortisone.
It's adaptive.
Exactly. It's adaptive. And so it's not only just immunosuppressive, it is immunosuppressive,
Yeah.
but it's not just immunosuppressive, it is suppressive. It is suppressive of everything. It's slowing all of your metabolic functions. It's directing that energy just towards the functions that you need to survive. Like these things that they're talking about as being immunosuppressive for something like an autoimmune issue, they are entirely suppressive. That's like how they're functioning. And so, yeah, it's not a pathway that we want to go down.
No, especially when there's other alternative methods to quell the inflammation without putting brakes on the system.
Yeah.
Because it comes down like, yes, you can lower inflammation, but how? That's
Right.
really the question is how? How are you doing it? Because you can lower inflammation, sure. If your arm won't be inflamed anymore if I cut it off.
Yeah. Yeah. Well,
if you won't have cancer anymore if I cut out the tumor, but that doesn't mean that you had to help the body out.
Right. And that's a whole other topic. But
the question is always how, and that's
right.
basically what we're saying. Is there a way to deal with these situations without having excess damage? And are there other methods to deal with the inflammation or deal with the cascades? Because a lot of people are with coronavirus, the biggest worry is ARDS, acute respiratory distress syndrome, and from a cytokine storm that was going around the internet for a while. And it's like, you can manage those things. We're talking about directly how to prevent those things from happening. And then again, they're even beyond the virus and the direct pathways. There are certain lifestyle factors that you can undergo, specifically when you mentioned omega-3s before, or polyunsaturated fats in general, where if you basically don't have, or you don't saturate your tissues with these types of fats, your ability to produce a massive inflammatory reaction is largely diminished because you don't have these compounds that propagate the response. You don't have something that it's basically like, at least the way I see it in my mind is, if you have your tissues loaded up on these types of fats, then essentially when you have an inflammatory response, it's like you just lit all of the fuses for dynamite in your body. It's just waiting for one little spark. Right. Whereas if you don't have that there, then you have the system set up to deal with that specific response in that localized area without completely deranging the entire systemic response. So something like a coronavirus or something like a bacterial infection, your body handles it. And when you could take something to help it handle it, and then it gets through it, no problem. Whereas if you have all these other things going on, and this is why people with comorbidities like diabetes, like heart disease, like whatever else, are acutely liable to get these infections and to have them become susceptible and have them become very severe. Because for somebody who has hypertension, for somebody who already has heart disease, their RAAS system is already massively activated. That is why they take drugs like ACE inhibitors, angiotensin converting enzyme inhibitors, or ARBs, angiotensin receptor blockers. These are or clonidine or centrally acting anti-stress drugs. These drugs are inhibiting these pathways because they're already ratcheted up. They're already elevated because the people are already in a chronically inflamed state. Or something like diabetes, where you basically have a derangement of energy metabolism across the entire body. These people's bodies are primed to be attacked by this virus. They're literally setting themselves up, not only the coronavirus, but the flu and bacterial infections. That's why you see with diabetics, they get infections like crazy, especially if you have any type of cut on the lower extremities or anything like that. Their body cannot heal. Their metabolism is not functioning well. The people with heart failure or heart diseases and things like that, you see that they have massive edema because the energy metabolism across the body is massively disrupted. So all these people in these situations, they already have these pathways active. So whether they get coronavirus or not, it's like, okay, if they get exposed, they will probably get it, especially somebody with hypertension, because their ACE system, their angiotensin, their RAAS system is already massively elevated. It's already deranged.
Mm. Which is that's shown in the literature that
exactly.
those people are all way more susceptible.
Yeah. So those people should be worried about getting something like this, especially because it hijacks a system that's already in derangement.
Yeah. And
we're not saying that it's not a problem. We're saying that there's other ways to prevent it, and these are the other ways to prevent it without making it worse. And don't get to this position to begin with.
Yeah. And for all the people who are already in that position, there's everything that you can do things to get out of that state. And obviously, like with something like coronavirus right now, you probably want to have some of the supplements we talked about on hand to protect yourself and help support you. But in the long term, if you improve your diet, improve your movement, all these other things that we've talked about, you will leave that state. So that way, if there's a future pandemic, which I'm sure this is not the last one, you don't have to be worried anymore. Like in the case that there is a future pandemic, which is entirely possible considering history,
yes,
you will be in a much better position. And and I wanted to mention also, somebody could, we're talking about kind of the reductionism of just looking at these certain pathways and, immunosuppression through these different drugs not being the answer. I want to point out too that when we're saying that something like aspirin or something like inosine, that those are helpful for stopping the inflammatory response, they're helpful for stopping it from the ground up. So they help to fix the issues with the metabolic apparatus that then lead to proper energy production and stopping of the inflammatory signals, even if they aren't always looked at that way, like for aspirin, for example. So these are compounds and things that help on that ground level. They aren't things that are just going to, from like the top down, like symptoms down, suppress the response.
They're very general anti-inflammatory, antiviral, anti whatever.
And it's not, it's like, and that's why it's I wouldn't call aspirin as, aspirin is an antiviral, aspirin is an anti-inflammatory. Like, it is those things, but it's deeper than that,
Yeah, it has a systemic metabolic, like a beneficially metabolic effect. Like it has a general most of the compounds we talked about have a general stabilizing effect on the entire system. So even when you talk about vitamins and minerals and sunlight and things like that, you are literally providing the system with adequate resources to maintain structure and energy production and handle assaults on the system. That is what they are there for. That is what the system requires. They are not these random compounds that have some type of like keyhole effect on the disease. I mean, something like losartan, yes, you were talking about something like that. But when you talk about aspirin, or you talk about Benadryl, or you talk about any of the vitamins or any of the steroids or things like that, they have broad ranging systemic effects. And even the drugs, when they talk about them as having one specific effect, like losartan is just an angiotensin receptor blocker. There's way more to the effects of that drug than just that.
Right, that's what I was going to say. Yeah.
The pharmaceutical companies have mapped out that as its specific effect, and they have marketed it brilliantly as this is its effect. But when you look in the research, multiple drugs and multiple compounds have many other effects. So that's why when you start looking at something like chloroquine or chloroquine or however you want to say it, then you start to see, well, yes, it has this effect, sure, and it's helpful in this one specific situation, but in the broad context, it is detrimental. And that's when you want to start having a context to look at things and say, okay, when you have something like aspirin, okay, it has this generally protective effect, and then it is also helpful. And then when you look at something like chloroquine or chloroquine, you say it has this one specific effect that's helpful in the situation, but it has a generally negative impact on the body. Or something like cortisol, where it has a generally negative effect. I mean,
but it's helpful for reducing inflammation temporarily. Yeah.
Exactly, but it's helpful. And the thing about cortisol, and that's why you need to know why and how. Those things are always important. Why is cortisol released? Cortisol is released in systemic inflammation to help deal with the inflammation, so that like it basically breaks the system so that it doesn't crash itself, but it doesn't solve the problem. And then you start to, and you can even see this in the general side effects when you take something like cortisone or any hydrocortisone or any solumedrol or any of these synthetic analogs of cortisol. the effects of those drugs are devastating. Diabetes, hypertension, thinning of skin, loss of hair, fat deposition, hyperlipidemia, literally metabolic syndrome. The side effects of these drugs are metabolic syndrome because they crash the metabolism. That is
Right.
literally what they do. That is their mechanism.
And
Now, are they adaptive in certain situations? Yes. Is
yeah,
there a need for them in certain situations? Of course. But extended use of these things or use of these things beyond those situations are not helpful. They are very damaging because the mechanism with which they function are a last resort. It is
mhm,
literally the body's last resort or one of their last resorts, or like
yeah,
it is a contingency system. When
mhm,
your house goes out of power, and the power system goes down, you don't expect to run your house on a gasoline generator perpetually. You basically run. You'll number one, you'll run out of gasoline, and number two, you smoke up the house if it's inside. So, and that's the analogy for something like cortisol or something like estrogen or something like serotonin or some of these other or some as general mediators, and then some of these other drugs. They have a devastating effect long term, and the short term effect is helpful only immediately.
yeah, yeah. I agree. Um, let's circle back to one of the treatments that's being used a lot right now for serious patients who have COVID-19, which is oxygen ventilation.
Mhm.
Um, where basically right now, a lot of people in severe states are being put on ventilators where they're given 100% oxygen, and this
Or
can actually,
varying percentages higher than normal atmosphere, because there's varying percentage of oxygen that you give people, and not everybody's being put on a ventilator, but just hyperoxygenating people in general oxygen is about 21% in the air. And then when in medical settings, what they wind up doing is there's a whole bunch of different apparatuses, masks or tubes or trachs or anything like that, that they can directly infuse oxygen into the lung system, and they can titrate or adjust the concentrations depending on the situation.
right, and I mean, and correct me if I'm wrong, but they're typically trying to reach a very high oxygen concentration
Exactly. So the way you
in the
determine
body, like in
exactly
our,
the
okay.
way they determine how the ventilators are working to a large extent beyond like the vent itself and its readings is they will look at either arterial oxygen saturation via an arterial line, or they will look at the saturation via a pulse oximeter, which uses infrared light to determine the concentration of oxygen on, or the saturation of oxygen on the red blood cells
Mhm.
or
And
in
so
the arterial blood in general.
right. And so while this is thought to be good, like, hey, you want more oxygen floating around in your blood, right? But this can actually be relatively dangerous and can actually worsen health outcomes pretty significantly. It can worsen mortality, and and this has been shown in research that this can actually be pretty dangerous. So, and basically the way that it does it is by causing what's called respiratory alkalosis. Do you want to talk? Do you want to talk a little bit about that?
Well, I guess the specifics basically is that there's a relationship between CO2 and oxygen and cell respiration. And when the cells respire or the cells produce energy through they call it cell respiration essentially, the cells use oxygen and they basically create carbon dioxide. So they take sugar and they basically burn the sugar, and the oxygen works in that cascade, and then they produce water and carbon dioxide from that process.
And
Now,
energy.
and energy.
Yeah.
So when you have the red blood cells are mediators between the cells and then the lungs and the general atmosphere. And so the red blood cells have basically an apparatus on them that when you have a high amount of CO2 or carbon dioxide, which you find at the cellular level because the cells are actively producing it when they're producing energy, the red blood cells will unload the oxygen that they pick up from the lungs. This is these effects are the Bohr and the Haldane effects. Now,
Mhm.
when you get to the lungs, the high concentration of oxygen will cause the CO2 that the red blood cells picked up by the cells to be unloaded to the atmosphere. So, and then basically the red blood cells will pick up oxygen. So there's sort of this inverse relationship based in the
Mhm.
context. At the lungs, red blood cells will unload CO2 and pick up oxygen. And at the cells, red blood cells will unload oxygen and pick up CO2. Now,
And when you say at the cells, you're talking at the tissue level, so that can be muscles, your liver,
yeah,
your
it could be
heart.
anywhere in the body, the brain, the heart, the muscles, your left toe, doesn't matter. Basically anywhere in the body, the cells all have a general energy production system in the mitochondria. It all occurs in the mitochondria. So from there, basically what happens when you force a lot of oxygen into the system, you raise the overall arterial oxygen concentrations to such a high level that essentially you inhibit the unloading of oxygen at the cellular level because the oxygen concentration at the red blood cells is too high. So basically it messes up that little switch that the red blood cells have, and then basically the cells start producing they don't produce any energy anymore because they don't have oxygen as the final electron acceptor. And you're basically making it worse because you're shutting down the respiratory apparatus of the cells. You're shutting down energy production, which is the basis of the entire system we've been ranting on for the past hour and a half or however long.
Yeah. Basically what's happening is that because there's so much oxygen being like put into the blood, that you basically have what's supposed to happen at the lungs, which is that you have this high oxygen environment, so you drop off the CO2, or the red blood cells drop off the CO2. That's basically still happening at the tissue level, where the red blood cells are like, hey, there's a lot of oxygen here. I'm supposed to drop off CO2, and I'm supposed to pick up more oxygen. But the cells are trying to give the tissues are trying to give the red blood cells CO2. So you basically are not able to offload the oxygen that's supposed to come from the lungs into the tissues. And so, as you were saying, that means that the tissues and the cells within the tissues cannot produce energy, or at least efficiently, without the oxygen. So what ends up happening, another way of saying it, is that when you have this ventilation of too high oxygen, you end up reducing tissue oxygenation. So the tissues end up with lower oxygen, which is the whole point in the first place, is that the tissues need to have enough oxygen to respire properly, to produce energy properly. And now that's just getting worse. And this has been shown to happen, for example, with hyperventilation. So with hyperventilation, you end up driving your oxygen levels too high in the blood and your carbon dioxide levels too low. And so this ends up, as we were talking about, reducing the offloading of oxygen at the tissue level. And then that causes all these disruptions in the energy production process. And so it's shown that just as a result, even of just hyperventilating, so if you have anxiety, you're just breathing too heavily, too quickly, that causes excessive lactate production at the cell level, which just means that these cells aren't respiring properly. They're not going through the entire process of energy production. They're stopping part of at the earlier parts, which produces a lot of lactate, which then leads to, again, this whole inflammatory process that we've been talking about. It drives that even further, and it drives the edema that we were talking about, including the pulmonary edema, which is the whole problem in the first place that's causing the respiratory distress.
Yeah, exactly.
So
the one thing I want to add before you continue is the reason that people are using vents or increasing oxygen flow to the lungs at like oxygen percentage to the lungs is because as we talked about before, the basis of the inflammatory cascade is so in the lungs, you basically have these little sacs, they call them alveoli. And this is where gas exchange occurs. So it's basically like a little sac and then wrapped around our blood vessels. And the blood vessels bring the blood, and then the alveoli has a membrane that allows the transfer of CO2 and oxygen. Now, when you have this massive inflammatory cascade at the lungs, those membranes become leaky. So the gas exchange becomes very inefficient, and basically the transfer of oxygen and CO2 doesn't work anymore. And that's what acute respiratory distress syndrome is. It is literally the inability to breathe despite receiving oxygen, because the membranes aren't perfusing appropriately. And so that's why, okay, so now we're going to force oxygen. That's the immediate thought. We're going to force oxygen in there. And basically what we're saying is that that's not necessarily the ideal way to deal with the problem. Ideally, what you'd want to do is inhibit the inflammatory cascade so that you can restore the lung barrier and you can get rid of the edema in the membrane so that it functions properly. That's what you want to do so that you can have the gas exchange occur. You don't want to slam oxygen. You want to make sure that the barrier is intact.
Yeah, and another alternative option would be if you are going to be ventilating with oxygen to include a portion of CO2 in there as well. So that way you still have enough CO2 to offload the oxygen at the tissue level. And that's been shown to reduce lung injury and reduce the inflammation that goes on when there's excessive, basically hyperoxygenation. So, yeah, and this is, again, this is only happening with very severe instances of people with the coronavirus, but I think it's a pretty big problem that's going on. I mean, it's always been going on, but especially just right now, it's probably not helping the people in that situation.
Yeah. The other option that they have available to them, and this is a little bit tangential, is something called ECMO. And I think that I haven't specifically read all the research on it, but I think that they may be finding better outcomes with ECMO. And what ECMO is, it's called extracorporeal membrane oxygenation. So corporeal means body. So it means extracorporeal, which means outside the body. And then membrane oxygenation is they have a synthetic membrane and a specific type of machine that basically oxygenates the blood for you. So what they do is they extract blood from the venous system, and then they inject it, or they have a catheter from the venous system that takes the blood out. The blood circulates through this machine, and the machine has a little membrane that basically performs the job of the lungs. So it pulls out the CO2 and reoxygenates the blood, and then the blood is injected back like right before the heart to be pumped to the rest of the body. And so basically what this does is it bypasses the lungs. You don't need to use the lungs anymore. And from what I understand, you also don't need to use very high concentrations of oxygen. You only need normal concentrations of oxygen because the machine is oxygenating for you. There's no need to slam. The only problem, obviously, is that the machine is pretty invasive because you have to catheterize large vessels to pull the blood supply from the venous vasculature and then reintegrate the blood supply into the arterial vasculature. But it overall, like as far as maintaining the CO2 and O2 ratios to maintain the energy apparatus of the cell, it seems to be a bit safer than just slamming oxygen into patients with ventilators and masks.
Yeah. Which, I mean, I haven't heard of that being like widespread, being used in any sort of widespread.
It's extremely expensive, and it's also like invasive and requires placement of the lines.
Okay. So yeah, definitely something that is just helpful to know, but not.
And you need specialists to run the pumps. Like okay. you need people who are specially trained to use the pumps, and the training to use the pumps is a little bit more entailing than the training to use a vent. Mm-hmm. Because the pump is much like if you turn the pump off in a lot of these situations or you mess something up, the patient is dead. Like they're not breathing by themselves. I mean, on vents too, depending on if they're paralyzed or not. But it's just it's a little bit more entailing than just the ventilators as far as I understand.
Yeah, well, it's definitely sounds like a treatment option that's worth like the medical community looking into more for the future.
Yeah.
So I want to talk about a couple of things in particular that are being suggested for supporting immune function, if you even can support your immune function, that whole thing, because there's this narrative that's been going around from some medical professionals that you can't boost your immune system or you can't support your immune system.
Really? I didn't see that.
Yeah. But yeah, it's really a nonsensical idea. I mean, at the very least, the medical professionals have to acknowledge that tons of medications that they use are obviously immunosuppressive. So I don't know if they're trying to suggest that only medications affect the immune system, as if all of the other research on vitamins and minerals and foods and sunlight and sleep and all these other things,
which is extremely extensive, probably more so than a lot of the drugs that they're using.
Yeah, not to mention
especially on things like vitamin D, which has thousands of articles on it, and vitamin A.
Yeah, I mean, there's probably tens, hundreds of thousands of articles on all these things, like research papers on all sorts of aspects of our environment that are not pharmaceutical that affect immune function. But I mean, by the same token, and this is an idea that's actually kind of suggested by the whole lock and key theory and everything, but pharmaceuticals work through the exact same mechanisms as everything else. Like they aren't unique in their pathways, just like we're talking about with the coronavirus and where these different medications fit in. Like medications are working through the same pathways as different nutritional components, as different things in our environment. So it makes no sense to create the separation like that only medications can support immune function or be antiviral, but nothing else can, even though other things affect the exact same processes in virtually the exact same way. And a lot of medications come from natural compounds anyways. A lot of them are coming from herbs or extractions from herbs, different
They just
compounds.
make them synthetic by adding different groups to them so that they can patent them, and when they're patented, sell them. That's literally all that occurs.
Right. And a lot of times the
I'm pretty sure
original
chloroquine came from the bark of a particular tree.
Yeah, it comes from quinine, which is in tonic water.
Yeah.
So yeah, I mean and a lot of the original versions of the drugs are just that extracted chemical, and then as time goes on, they add more things to it. I mean, it depends on which one, but like
And
aspirin,
generally the drug and this is what makes a lot of the drugs dangerous, because a lot of the drug compounds that you see for even the antibiotics, a lot of they come from, even the cephalosporins come from fungus. The penicillin comes from fungus. Erythromycin, bacitracin, some of those come from bacteria. A lot of times what the companies do is they find these singular compounds and they extract them from a mix of different compounds that all have a different set of effects. And they isolate it, and they extract it, they isolate it, and then they add groups to them to make synthetic compounds, or they leave the compounds as they are and they sell them as is. And when you start to get, because with a lot of these things, the dose, it's not necessarily the dose makes the poison, but in cases it does, but also different dosages have different effects. When you change, just like, for example, in biology in general, when you have different concentrations, they function in different ways. So, for example, with what we were talking about earlier, with angiotensin 2, the concentration changes the effect. With a small amount of angiotensin 2 circulating, you don't have such a big deal. When you start increasing the concentration to certain levels and you reach thresholds, then you start having issues. That's when you start to turn on the system. And the same thing happens with these compounds. When you start extracting specific compounds from plants, if you were to just use whatever random herb or bark that it had there, I'm sure it would have the effect. When you extract the effect, and it doesn't mean that extraction is bad, it just means that the effects are changed, and the side effects are changed, and some of the negative effects are changed. And it goes with the drugs. The only difference in potency with a lot of them is sometimes when they add these extra groups to change the effects. So, for example, when you use some of the penicillin antibiotics and you add the beta-lactam inhibitors, which is the specific compounds that inhibit the bacterial enzymes that break down the penicillin or the different antibiotics, whatever it is, then when you start seeing, when you add those compounds, those change the effects, and they add different side effects and whatever else, and they change the metabolization of whatnot, but they still all work on the same pathways. The pharma drugs are just basically changing the structure a little bit so that they can patent it, or they're changing the concentrations and isolating compounds in high levels. And those things, they can start to become dangerous because, number one, when you change the structure, you don't know what other effects it has. And number two, when you start changing the concentrations, it changes the effects. And I mean, that's why they have all the extensive testing, because you have to go see what it does to animals first, and then you have to see what it does to humans. And then certain people, like, for example, Dr. Pete have mentioned that you don't know the safety of a drug until it's been in the population for decades, because some effects of drugs can happen or can change the effects decades down the line. You don't know.
Yeah.
And so another thing to talk about, and you may want to take this out or not, but when they start talking about streamlining vaccines and creating synthetic vaccines by messing around with different RNA sequences that are supposedly similar to the coronavirus, those should send red flags in your mind and say, oh, we're going to streamline this vaccine. We don't have to go through animal testing. We're going to put it right in the population. That is a problem. That is very dangerous, especially when you start messing around with RNA sequences and things like that. We don't know how it's going to work. We don't know what its effects are going to be. And for example, when you have slight changes in amino acid sequences, for example, with dairy or milk products, the difference between A2 and A1 casein, which has the different opiate effects, is a very slight change in amino acid sequence. Or when you have different like aberrations in enzyme function causing genetic diseases, those are very small changes in amino acid sequences on proteins. So when you start messing around with things like that, you don't know what the broad-ranging long-term effects are. So like it becomes very dangerous, and those are things to consider having red flags about in your mind. Hey, they streamlined this vaccine. It's not a weakened or attenuated virus or whatever else, depending on, or basically it's not weakened or attenuated. Now it's a synthetic mRNA strain. We don't know how it's going to work. We haven't tested it. And even if they did test it, the question is, we don't know what the long range effects are.
Right.
So
The regular testing that goes on with vaccines is
it's also questionable,
to say the least. Yeah.
So that, to be fair, though, we're not saying that we are opposed to vaccination. We're just questioning the current methods in which vaccinations are brought about.
Yeah. It's
just, that's it.
Yeah. So that was one thing that I wanted to touch on, was just that idea that we can't affect our immune system by anything other than pharmaceuticals. I just wanted to address that real quick. But there's a couple other things that people are suggesting that we should be doing to support immune function that are not so supportive. One of those is using omega-3s, which come from fish oil or fatty fish, and are pretty strongly immunosuppressive. And so in the same way that we were talking about drugs that are immunosuppressive, or cortisone being immunosuppressive, omega-3s follow in that same pathway. And it can be looked at as positive if you think of that as having a positive spin. But I think if most people consider that the effects are basically paralleling cortisol, which is one of our main stress hormones, then you might want to reconsider that. And and that's shown pretty ubiquitously. And I'll link to a couple articles that I've written regarding omega-3s and polyunsaturated fats in general. But specifically with COVID-19 as well, there's a couple studies showing, or not necessarily COVID-19, but specifically with acute respiratory distress syndrome, so ARDS.
Yeah.
Polyunsaturated fats have been basically implicated in that scenario, where either the damage to these fats, which omega-3s are very susceptible to, that's been associated with ARDS, and then also just the elevated presence of unsaturated fats has been shown to increase susceptibility to ARDS. So those are just a couple of very specific instances where that suggests that we might not want to be eating a lot of those things. But in general, if you want to call omega-3s anti-inflammatory, it's the same as calling cortisol anti-inflammatory, which is that, yes, there's a short-term reduction in inflammation, but what you're really doing is suppressing the immune system, suppressing our metabolism, and in the long term, that has, a lot of dangers that come with it and long-term damaging effects. So
I think specifically for omega-3s, it's important to mention too that their anti-inflammatory effects are mostly present in people who are very high in omega-6.
True. That as well.
And it's because of the interaction of omega-3s on the COX and LOX enzymes, which are inflammatory mediating enzymes, inhibiting basically the omega-6 conversion into prostaglandins and things like that, because of the effects of omega-3s on the enzymes. Yeah. So it's not like even beyond that. So say it does have the anti-inflammatory effect. Loading up your tissues on omega-3s has been directly shown to, number one, deplete vitamin E status, and then to also increase the production of lipid peroxidation species. So regardless of whether or not it has that anti-inflammatory effect immediately, it has a direct destructive effect on structure of cells and body tissues and things like that. And then lipid peroxidation products are highly implicated in like arterial sclerosis and heart disease and things like that. And so if you want loading up on those and damaging vasculature from lipid peroxidation products would probably, and this is just my hypothesis, would probably make the RAAS system, would probably increase RAAS system activation and aldosterone and cortisol and things like that due to the damage of the vasculature.
Yeah, so down the line. Yeah.
Down the line, yes, down the line over time. Yeah. So I think staying away from highly unstable fats would probably be a good idea.
Yeah, and we'll have future episodes talking specifically about that. But yeah, the couple of concerns, the one that you touched on is that they're very unstable, very susceptible to lipid peroxidation. And then that instability when they're integrated into our cells also leads to basically disrupted cell metabolism and basically leaking of energy. And yeah, there's other issues too, but they
have broad systemic negative effects, regardless of the immediate anti-inflammatory effects.
Right. Yeah, and then a couple other things that have been talked about. One we already mentioned was drinking a lot of water, that people are suggesting that, and we talked about how that might not be the best scenario. Don't want to be forcing water. Typically, our thirst is a good indicator of how much liquid we should be drinking, and we want to make sure we're getting enough salt. And I'll link to some articles dealing with both of those things.
Yeah, salt, magnesium, potassium. which is why earlier when I mentioned drinking fruit juice, you basically, I mean, beyond salt, you can add some salt to your food. But the fruit juice in general comes with a tons of minerals and vitamins and whatnot that is the fluid is essentially osmotically balanced. So, I mean, a lot of juices aren't very high in sodium, but they tend to be higher in potassium and other minerals and things like that. And then you can obviously just add a salt to taste your food. I mean, another thing to point out is when we say that salt is helpful, it doesn't mean that you have to drown yourself in salt. It just means that you salt to taste. Whatever your body is asking for in regard to salt, you meet that requirement, and then that's basically it. You don't have to, like, I've seen people where you say salt is helpful and then they use salt like as a crutch, like as a direct supplement for things, and eat obscene amounts of salt. No one is saying that is helpful either, because again, there is a mineral balance, there is an osmotic balance that needs to be maintained in the body, and like loading up extremely high levels of salt may not be helpful for that.
Yeah. And I think that's enough as far as covering like the water salt issue. A couple other things I wanted to touch on. Some people are suggesting fasting for improving immunity, and I mean, this is a lot of the community that thinks that fasting is a good idea. We definitely don't, and would say that that's probably the best way to drive stress hormones, including the RAAS system.
Through adrenaline and noradrenaline.
Yeah.
And then also increasing cortisol, lowering thyroid hormone, lowering androgens, and then at the same time increasing growth hormone and affecting energy metabolism, because the growth hormone is released in order to liberate free fatty acids.
Right.
Which we will go into at another episode, the difference between running on fat and running on sugar.
Yeah. So we'll leave that for another time, but that's at least like just kind of baseline, not something we support.
Wait, before you go off that topic, a lot of people talk about fasting being good because it basically resets the immune system. And I don't know if you've seen some of the stuff where they show basically like the immune system during extended periods of fasting. I forget the specific amount of time, but during the extended periods of fasting, you basically get a reduction of a certain type of immune cell. I think it was white blood cells, and then they basically are recreated when you finish fasting. And people are saying that that's a good thing. I'm not necessarily sure that's such a good thing, because with an absence of those immune cells and whatnot, I would probably say in that period of time you may be immunosuppressed.
Yeah. Not to mention, I mean, the whole idea of needing to like recycle cells and clean things out. I mean, those
that is the job of the immune system regularly.
Right. Those things
should recycle cells, but to clean out damaged tissues and whatnot.
Yeah, those things should already be happening at a regular level, especially if your metabolism is functioning well. And if those things are happening at a lower level, it doesn't mean you want to drive that process. You want to fix the underlying issues. And so, yes, fasting is really good at stimulating autophagy, for example. But you don't want to stimulate autophagy. You want the right amount of autophagy to already be going on based on having a proper functioning metabolism. And to reduce these kinds of things to, these parts of, you need to recycle your cells and you need to do this. I mean, it just leads you down this dangerous road, and all things we'll talk about in the future. But yeah,
I just think the basis of it is not very helpful. I would say, just to give some lip service to this, the benefits of fasting that I would say are, if you do have some type of gut issue going on, then lowering endotoxin, which is a product produced from bacteria, it's a component of their cell wall. Lowering that does help the immune system and does help the energy system and the metabolic system overall. So there may be some benefit there. But as for increasing adrenaline to really high levels and growth hormone and lowering thyroid and lowering sex steroids and things like that via fasting, and then increasing autophagy through those means, I don't think that those are a good idea. And then also increasing cortisol. It's basically a catabolic process. It's not. I don't think that that's ideal.
Yeah, it's a major stress process. And so you, just like when you're looking at omega-3s or cortisol or these medications, fasting falls in that same category, where you can't just look at these end targets or these certain pathways. You need to understand the full system to understand whether these things are actually helping you.
Yeah, or cold exposure.
Yeah, all of those things. Hormesis.
Hormesis.
Yeah, which I have a whole article touching. I mean, I guess I might as well reference that I have an entire article talking about that whole paradigm and that thought process, that you want to be causing small amounts of stress because that stimulates these repair pathways. It's a pretty extensive article because there's a lot to go through, but I'll link to those in the show notes.
Yeah.
The only other thing that I wanted to mention as we kind of wrap up was just the effects of fear and stress on our immune function and on our health in general. And that, trying to limit those sources of fear and stress are probably really helpful right now, especially right now. So whatever that, that can mean different things for different people, but probably staying on your phone less, being out in nature more, getting more sunshine, which is also directly helpful for all these other things.
Stop watching mainstream media.
Yeah, be careful of your media intake, social media as well. All of that stuff is I think incredibly important and especially right now. So,
yeah.
Do you have anything else you want to add?
No, I'm good.
All right, then we'll leave it there. All right, that's going to conclude episode 0 of the Energy Balance podcast. I hope you guys enjoyed that episode. And if you did, please leave a review or a like or share this episode with anybody that you think would benefit from hearing this information. To check out more of my work, head over to jfeldmanwellness.com. And for Mike, you can head over to sapiensystems.com. And then to check out the show notes for today's episode, which will include links to all the different things that we talked about, the research supporting our points, head over to jfeldmanwellness.com/podcast. And then if you are dealing with any low energy symptoms or chronic health conditions that we talked about throughout the episode, or if you're dealing with brain fog or fatigue, gut issues, weight gain, or if you just want to make sure that your immune system and your metabolism are functioning optimally, head over to jfeldmanwellness.com/energy and sign up for a free mini course on energy balance. And I'll walk you through the things to do to support energy production and the things to avoid that inhibit that process, of course. We talked through some of those today, but there's a ton more to get into. So head over to jfeldmanwellness.com/energy to check that out. And I will see you in the next episode.